Okay, so number 4 in section 2.2 is asking us to sketch this piecewise function f of x equals 4 plus x if x is less than negative 2, x squared if x is between negative 2 and positive 2, with the negative 2 being included, and then finally 6 minus x if x is greater than or equal to 2. So if we just go ahead and draw a coordinate plane, we can sketch this. So what we have here is three functions defined over specific intervals. Okay, so for the first one, 4 plus x, that is a linear function, and it's defined on the interval when x is less than negative 2. So if we come over here to negative 2, we can substitute the negative 2 in here. So 4 plus negative 2 gives us positive 2. So we go up to 2, but remember, we don't include, this x value is not included on this interval, so we're going to have an open circle there. And then from there, we can either just use the slope. So the slope on this is 1, so we go positive 1. But since we're not defined to the right, we're not going to go up 1 to and over 1 to the right. We'll go down 1 and left 1. That's our second point. And that's that piece of the graph. It goes like so. The middle piece is a parabola. We know that because it's just a function that you should have studied in college algebra, and it's defined on the interval from negative 2 to positive 2, with the negative 2 being included. So you always use the endpoints when you have these intervals. So let's put the negative 2 in, and we get a 4. So if x is negative 2, then f of x equals, or f of x equals 4. So that's a closed circle because once again this has the equal to on it, it's included. And then put the positive 2 in, we also get 4, but that's not included on the interval, so there'd be an open circle there. If we put a 1 in, we get 1, so 1, 1, negative 1, 1, 0, 0. We know this is a parabola, so it's going to have this general shape here. It's kind of ugly, but you get the idea. And then finally we have another linear piece, 6 minus x, and it's defined on the interval when x is greater than or equal to 2. So let's go ahead and put that beginning point of that interval 2 and see what we get. 6 minus 2 equals 4. So if we go 2 to 4, now this gets filled in because it is defined there, but it's defined from the third piece, the 6 minus x, not the x squared. And if we use the slope negative 1, so it tells us to go down 1 and right 1, and that's our second point, and our graph looks like so. So the next part of this problem is asking us to look at the graph that we just graphed and find the value for a where the limit of f of x as x approaches a does not exist. So for the limit to not exist, we need to take the left hand limit and right hand limit, and they should not be the same thing. So anywhere on this graph, this is going to be true except for when a is negative 2. And let me draw this in a separate color. So as x approaches 2, let's just take this into consideration. From the left side, the left hand limit is approaching 2, and the right hand limit is approaching 4, so that doesn't exist. So this is the case where a is equal to 2. So once again, we're trying to figure out when this did not exist. So you can see that the left hand limit and right hand limit is not the same thing at the value where a is 2.